So first of all, I'm going to explain the mechanism. So immune activation of coagulation, if we actually break down this term, immune activation, that means the innate immune system. So the inflammation from the innate immune system is driving coagulation. So the inflammation from the innate immune system is driving dysregulation in the blood clotting system. So we have two different systems here that are being interlinked by inflammation, and therefore you have two different types of dysregulation. So what is it about the immune system that is actually driving the blood clotting system to go wrong? Okay, well, first of all, if we actually frame immune activation of coagulation in mold illness, in biotoxin illness, in chronic inflammatory response syndrome, it's the mycotoxin. So it's the fungal toxin driving inflammation in the innate immune system. And this inflammation in the innate immune system is causing an increase in fibrin. Okay, so that's how the two systems link. Fibrin and fibrinogen is from the blood clotting system, and mycotoxins and that inflammation that's driven by the mycotoxin is from the innate immune system. So you can see that's how the two systems link. So how do they link? Well, the more inflammation that you have in the body driven by the mycotoxins, the higher your dysregulation of blood coagulation. Now, this means that there's going to be an upregulation in fibrinogen, which means there's going to be more very thick, fibrous chains of fibrin being laid down on your blood vessel walls. And they're laid down on every single type of blood vessel wall. So they're laid down on your microcapillaries, on your capillaries, on your central line, on your secondary line. They're laid down everywhere. But this is actually more problematic when the fibrin layer, so if you can imagine layers of fibrin, so this is actually more problematic during the microcapillary environment because we don't have a lot of room for error in the microcapillary environment. So within the microcapillary environment, we don't have a very large room for error. So having an increase in the innate immunity inflammation, which then leads to blood coagulation systems going haywire within the microcapillary environment, is very difficult to overcome, because essentially you end up with a very, very small diameter of microcapillaries being laid down with very hard fibrous fibrin chains. Now, what this means is that oxygen cannot diffuse into the cell and waste products cannot diffuse out of the cell because of the fibrin chain. You basically have a block, it's like a roadblock that's causing hypoxia in the microenvironment, and the roadblock is the fibrin. And the fibrin is caused by an upregulation in fibrinogen, which is caused due to the increased inflammation of the innate immune system. So I'm trying to make it simple. It's a very hard topic to understand. It's relatively a hard topic to explain. I'll try and put some infographics actually here. I do actually have some very good infographics. So okay, I'm going to pretend that there's an infographic. So essentially you can see the fibrin and you can also see the microcapillary. And within the microcapillary, you can see we don't have a very large diameter to work with. So basically the more fibrin chains that are laid up within the microcapillary, the harder it is for oxygen and for waste products to exit and enter the cell. So at the same time, this actually means the cell becomes hypoxic. And when the cell is hypoxic, it means there's not enough oxygen in the cell. This can lead to other pathologies, such as cancer, which is somewhat known as the Warburg effect. A Nobel Prize was actually won for the Warburg effect, and it's to do with hypoxia and cancer mechanisms. If you want to check out the Warburg effect, I suggest that you do so. And there's also a very good book by Dr. Thomas Seyfried who explains the Warburg effect in cancer. So essentially, when we go back to mold illness and CIRS, this actually means that as well as oxygen and waste product removal, so oxygen delivery and waste product removal, you actually cannot get the cell to accept large steroidal cholesterol hormonal molecules like T3 and T4. You also cannot get the cell to really, signal. It's very hard for the cell to signal, and essentially the cell ends up in senescence. So you can kind of see the timeline. So someone would have a very high mycotoxin load. Maybe they have an internal colonization. Maybe they've just lived in a mycotoxin environment for a long time. And actually, over time, this builds up inflammation in their innate immunity. And when it does build up inflammation in their innate immunity, you will have a rise in fibrinogen, and then consequently, you'll have a rise in fibrin. And over time, the fibrin chains are going to be building and creating very, very thick layers of fibrin within the microcapillary vasculature. And over time, this leads to less and less and less oxygen diffusion, less and less and less waste removal, and less and less and less signaling. And this signaling may also be peptides, amino acids, cholesterol, steroidal based signaling. Actually, these people tend to be very treatment resistant. So, people who have very high immune activation of coagulation are treatment resistant because the cells cannot accept the supplements and the peptides and any other actives that you're trying to deliver to the cell. So, as a summary point, I hope you can understand that number one, we end up with high innate immunity. So, very high innate immunity, which leads to number two, an increase in fibrinogen and an increase in fibrin, which leads to number three, damaged microcapillary environments. And within those damaged microcapillary environments, you of course end up with senescent and hypoxic cells. So that is the overall description. I hope you understood in the best way possible. And there is a way to overcome immune activation of coagulation. So there is a peptide that is referenced in peer-reviewed studies on PubMed. And this peptide reduces immune activation of coagulation by 475%. And this is referenced. And there's also other IVs that you can undergo. EDTA IVs are an amazing way to strip away the fibrin, and allow the microcapillaries to breathe again. Also, heparin. So this is actually more common in long COVID, but a lot of people are undergoing heparin blood washing. So actually having your blood washed out with heparin to remove fibrin chains, because heparin is amazing at breaking down fibrin chains. There's also ozone therapy, EBO2, but there are therapies in place that we can use to help you overcome immune activation of coagulation. The main goal in immune activation of coagulation is number one, to reduce the innate immune system inflammation, to actually downregulate fibrinogen, and actually number two, to strip away the fibrin that is built up in your vasculature. Actually strip it away. Physically, we need to strip that away. I don't know if there's any targeted supplements out there. Obviously, the kinases, nattokinase, digestive enzymes, serrapeptidase, and those kinases. Those kinases are also very good at stripping away the fibrin, but an actual targeted supplement would be an amazing idea. So if anyone wants to go into drug development, no one's really looking at fibrin. But essentially, we want to actually physically remove the fibrin from those vascular chains. So I hope that made sense. If you actually feel that you have immune activation of coagulation, we can get you tested. So there's blood testing markers for immune activation of coagulation. It's pretty interesting when you get a very treatment resistant patient, you get a very treatment resistant individual, and they come back and they actually have genetic alleles promoting immune activation of coagulation, because you can be genetically predisposed. And also they'll have other markers that are showing that they have high immune activation of coagulation. So if you feel like you have high activation of immune coagulation and you'd like to work with me to overcome immune activation of coagulation, then we have multiple different therapies. Whether you're in Dubai or remote, we can adapt and apply all the different therapies to you. And if that is you, then you can get in touch with me using the links below. You can book a consultation, you can book a discovery call, or you can just email me to find out more. I do work in Dubai within clinics to deliver more invasive procedures, and I can also coach and consult people remotely too. So get in touch. I would love to hear from you. I'd love to help you because immune activation of coagulation, it's a very difficult one to be aware of, and it's pretty difficult to treat as well. You need a very systemized protocol and it can take a little bit of time. Personally, I would love to have everyone to come and undergo ozone therapy or blood washing or EBO2, but there are therapies that we can do, such as peptide therapy, to reduce this immune activation of coagulation. Like I said, there's a peptide that reduces this by 475%. So I look forward to seeing from you. And if you're wondering about my flowers, it was Valentine's Day a few days ago. So I have very beautiful roses. I love roses, they're my favorite. So happy Valentine's Day for everyone who celebrated, and thank you so much for watching. I look forward to speaking to you very soon.